Today we're talking about something super top secret. We're going to be talking about completing the square using perfect square trinomials.
What if we think back to the different methods that we've used for factoring quadratics? We've talked about using the cross method to factor, and that's fine and dandy. We've talked about graphing quadratics in order to find the solution, which is also fine, especially if you love graphing, but there are some things that make it a little difficult. But what if I offered a solution that would help you factor any quadratic just by turning it into a perfect square trinomial? Aha, I see you're interested. Well, here's what we're going to do. Before we get to that, we're going to take a step back and maybe look at a chart. And what we're going to do after looking at the chart, you're going to find a pattern. You're going to see a pattern that's going to help you realize the relationship between perfect square trinomials and their C values, which is going to lead you to figure out why you can turn any quadratic equation into a perfect square trinomial in order to solve. So here we go. Let's take a look at the chart. I have the following table where I have my p-value. The next column represents x plus p squared, so what it would look like in factored form. The middle column shows my expanded perfect square trinomial. I have my b value and my c value in the final two columns. So for example, if I take a look at my first value that's incomplete there, incomplete. Did I just say incomplete? Yeah, I guess I did. Alright, so it's going to be x plus 3 squared, which expands to x squared plus 6x plus 9. So we're going to take a look now. My b value is 6, and my c value is 9. Pretty straightforward. So what I'm going to go ahead and do now is go through the rest of the table, and you can go ahead and fast forward if you want through this, or you can go ahead and work on this table on your own, because it might go ahead and give you a little refresher as to how to relate perfect square trinomials from factored form to expanded form and vice versa. Do you remember the shortcut for how a perfect square trinomial works? If not, it would be useful to remember because it certainly makes life a lot easier. Now we're looking at the middle column. It's already solved in expanded form. So I know that factored form looks like this. And now I have my values again. And then I keep going. Because I'm the kind of guy who likes to see things through to completion. And if you really want to, you can tell those who fast-forwarded through the rest of the table that I gave them some sort of secret answer to the next math test. That's what they get for forwarding through. And here's where things start to get interesting. Because as I'm writing things down, you might notice a pattern between the B column and the C column. If you don't, that's okay too. But I promise you there's a pattern. There's a relationship. If we take a look at 3, I know that's my B value. So I input the value x squared plus 3x. But now I need to figure out that last term. How am I going to go ahead and do this? Well, for those of you who've seen a pattern, maybe you can see that my factored form is going to look like this. And which means my expanded form will look something like this. All right, have we figured out the pattern yet? Do you notice a relationship between B and C? Between this value and this value. This value and this value. This value and this value. If you do, then the next problem, -5, you should be able to see that we notice that the B value, or if we take the B value and cut it in half and then double it, we end up with the C value. So our factor term here will be x minus 5/2 squared. And so our expanded form will be x squared minus 5x plus 25/4. And then we'll see over here that term, that -5/2. All right. What does that have to do with the price of tea in China? Let's take a look at this problem. So the figure is made up of a square and two identical rectangles. There's a reason they're identical.
Perfect square trinomials.
First thing we're going to do is find the area of 1 and the area of 2 and the area of 3. So the area of 1 is x times x, and that's going to get us x squared. Area 2 is going to get us b over 2 times x. So x times b over 2. And then we're going to have, again, x times b over 2. Now when we add those two together, what do we get? Think about it, 1/2 b plus 1/2 b is going to be a whole b. So we have x squared plus bx plus, now let's talk about this value here. So first I have x squared plus bx, talking about those three values. Now if I want to make that figure a square, what do I need to add in order to make that part a square? Well, sure, you could say c, but it's going to be b squared. If we look at things mathematically, here's b squared times b squared. So it's going to be b squared, or sorry, b over 2, not b squared, b over 2 squared. Haha! So what you'll notice is we've made a rectangle out of our shape, but not only is it just any kind of rectangle, but rather it's a perfect square trinomial. So what we can see up at the top is that the expression x squared plus bx becomes a perfect square when b over 2 squared is added to it. So if you take a quadratic equation by using this approach, this is called completing the square. So what does this mean, really? Well, let's take a look at x squared plus 6x minus 7. And what we're going to do is complete this, we're going to complete the square in order to solve this. So the first thing I need to do is move the constant to the right-hand side. So that's going to get me x squared plus 6x equals 7. So now on the left-hand side, you'll notice that it's not complete. I have x squared plus 6x. I need to complete it in order to make it a perfect square trinomial. So I'm going to take my middle term, or my b term, which is 6, and I'm going to cut it in half. So I have x squared plus 6x plus 6 over 2, so half of 6 squared, now equals 7. Remember, whatever you do to one side, you have to do to the other. So I'm going to go ahead and add 6 over 2 squared. All right, so as we move this through, now I have x squared plus 6x plus 3 squared. 6 divided by 2 is 3 squared. And really we know that that's 9, but there's an important reason for why we're thinking about it in terms of 3 squared. Equals 7 plus 6 divided by 2, again that's 3 squared, and that 9, that's 16. So x squared plus 6x plus 9 equals 16. Mr. Chavez, you've made my life more difficult. Hold on, just wait a minute, because x squared plus 6x plus 9 is a perfect square trinomial, which we know factors to x plus 3 squared. So x plus 3 squared equals 16, which means I have two potential solutions, because now I need to get rid of the squared, and we know the only way to get rid of a square is to take the square root. So I'm taking the square root of both sides, but now if we remember, if we take the square root of 16, there are two different answers we can get. We can get 4 times 4, which is 16, but we can also get negative 4 times negative 4, which is 16. So you always have to remember that there's a positive or negative when you're taking the square root. So anyway, let's go back to this problem. So now this tells me that x plus 3 could equal the square root of 16 as positive 4, or x plus 3 equals negative 4, because again, negative 4 times negative 4 equals a positive 16. So now I have my two solutions. I can set that up as x equals 1 or x equals negative 7. Those are my two solutions through completing the square. Now what you're saying right now, I know you're saying it right now. Alright, not all of you, but about a third of you are saying, couldn't I have just used the cross method with a little guessing and checking to get my solution? Yeah, you probably could have. But let's take a look where the solution is not so readily apparent when completing the square. X squared minus x minus 3 equals 0. You might say there are no numbers that will work. Well, it's true that there are no whole numbers that would work. Ah, yes, you see where I'm going with this. Alright, so first thing we're going to do is move the negative 3 to the right hand side. So now I have x squared minus x equals 3. We're going to go ahead and complete the square on the left hand side, which means I'm going to take half of my b term, which my b term is negative 1, so I'm going to take half of that and then square it, so it's going to look like x squared minus x plus, in parentheses, a negative 1/2 squared, and that's going to equal 3 plus a negative 1/2. Squared. Which again, I can expand that negative 1/2 squared to x squared minus x plus 1/4 equals 3 plus 1/4. I could if I wanted to. But what we're going to see is that this x squared minus x plus 1/4, the important part is getting it to where it's the factored form of a perfect square trinomial, which I know if I take x squared minus x plus 1/4 and I factor it, it has to factor down to x minus 1/2 in parentheses squared. And that's going to equal 3 plus 1/4. Now you might be tempted to add it together, get 3 1/4, but I encourage you to use a fraction, to change it to 13/4, and you'll see why in a second. What we're going to do now, get rid of that square by taking the square root. I'm going to take the square root of both sides, remembering again the positive and negative values. I have my two answers now set up as x minus 1/2 could equal the square root of 13 over 2, because the square root of 13 over the square root of 4, and the square root of 4 we know is 2, or x minus 1/2 will equal the negative square root of 13 over 2. So you see how all the units that we've been working on for the past couple of weeks and months are leading up to this point, leading to this math. So now this means I have x equaling the square root of 13 over 2 plus 1 over 2, which is about 2.30. Or we could write that as the square root of 13 plus 1 over 2. Or my other answer is going to be x equals the negative square root of 13 over 2 plus 1/2. So x is going to equal about a negative 1.3. There are the two answers that I got. If I were to solve the equation graphically, I could probably get close to that answer. I couldn't find that answer by using the cross method. I can do it by completing the square. And if you're not very happy with completing the square, it's okay. You practice it a while, you'll get better at it. What we see next time will be something even better.